All right, we're good to record now. We're on section 10.1. The title is counting principle. So the first page is kind of about the counting principle, and then permutations, which we'll talk about if you've never heard of that. Example 1, at a blood drive, blood can be labeled one of the 4 types, A, B, AB, or O. One of the 2 RH factors, plus or minus, or positive, negative, and one of the 2 genders, male or female. Use a tree diagram to find the number of ways blood can be labeled. So let's go ahead and do your 4 choices. You have A blood, B, AB, or O. I'm going to do my tree sort of vertically, but there's many ways to sort of draw it. Now, if I'm blood type A, I could be A positive or A negative. Same for if I'm blood type B, positive or negative, and so on. And then if I'm A positive, there might be one labeled A positive male or A positive female. So from each one of these, it could be labeled that it's from a male or female. So we're using our tree diagram to find the number of ways blood can be labeled. So how many ways could a unit of blood be labeled with a sticker on it? Yeah, you just count the outcomes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 16 ways. Now, tree diagrams are great for visuals. Can anybody tell me a downfall possibly to tree diagrams?
They could take forever to list out.
They could take forever. For example, if I said, let's make a tree diagram of your possible schedule. So your first hour classes, you have these to pick from. Your second hour class, you have these to pick from. That would take you a day to just do 2 class periods. So they're great, but they're not the best all the time. B, if all blood types are equally likely, what is the probability that a person has A positive blood? Write your answer.
Wait, is it not A positive blood? Oh.
That a person has A positive. You don't have to write everything I did, but I wrote P, probability of A positive, which means I want the A positive blood over the total. I just found the total from previous problem. How many have A positive? These 2 have A positive. So 2 out of 16. So 1 out of 8. The fundamental counting principle, you can follow along. 2 events. If one event can occur in M ways and another event can occur in N ways, then the number of ways that both events can occur is M times N. Three or more events. The fundamental counting principle can be extended to 3 or more events. For example, if 3 events occur in M, N, and P ways, then the number of ways that all 3 events can occur is M times N times P. Let's see if the counting principle applies here. I had 4 blood types. I had 2 RH factors, and I had 2 factors for gender. I pick one of those out of the 4. I pick one of those out of the 2, and I pick one of those out of the 2. 4 times 2 is 8, times 2 is 16. We didn't even need a tree diagram, but it's nice to see how we got that. Have we heard of the counting principle before? Some have, some haven't. Okay. It only works if you're picking one object. So like if this was, let's say I have 5 flavors of ice cream, and 2 toppings like chocolate sauce or caramel sauce, then the number of ways I can make my sundae is 5 times 2. This only works if I'm picking one flavor of ice cream, not putting several in, and one of the 2 toppings. Got it? If it says pick 3 or more flavors and 1, 2, or no toppings, that's a whole different problem, which we will get to, but not just the counting principle. Example 2, at a used bookstore, you are interested in 5 novels, 3 books of nonfiction, and 7 comic books. You buy 1 of each kind. I'm just mentioning that's important. We only get 1 of each. How many choices do you have? We don't have to make a tree diagram. I want 1 novel. There's 5 to pick from. I want 1 of the nonfiction books, and I want 1 of the comic books. Do you have a question? Are you recording? Yes, thank you. What does that come out to? 105. Like I mentioned, if we had a question that says you are going to pick 2 novels and 2 nonfiction and 5 comic books, the counting principle will not work. There's a whole separate way to go about that problem. That's either later today or a different day. Example 3. The digits 0, 1, 2, 3, and 4 are used to generate a 4-digit customer code. How many codes are possible if the digits can be repeated? I think we've done problems like this. I always like to write out, okay, I know I'm going to have 4 digits that need to be filled. How many different choices are there for this one right here? 5. 0, 1, 2, 3, or 4 is actually 5 choices that I could put there. Now, if I pick a 1, I can repeat the 1. So how many choices do I have for this spot? 5 in this spot, 5 in this spot, 5. Multiply that out. Thomas, what do you get?
625.
Yep. Let's just go to the next one. Same idea. We have 4 numbers to fill. They cannot be repeated. How many choices do I have for this first blank?
5.
How many do I have for the next one?
4.
4. How many for the next one?
3.
Right. I'm using it so it cannot be used again, so that makes 1 less choice. Thomas, I'll take that number again, too.
120.
120. Thank you. All right, C is a thinker. So read that a couple times, jot some notes down, and we'll see if anybody gets C correct. Take your time.
Oreo, cookie dough, or mint chocolate chip?
Cookie dough, chocolate chip, mint chocolate chip. Thank you. Were they mad that you came
No.
down here from the high school?
No. So I'm getting stuff on your desk, but they're melting a little
It's
bit. Spoon,
Yeah. Oh, these are cool spoons.
napkin.
Oh, I'll be fine.
Okay.
Thank you. Mm. Thanks. I feel better. Thank you. Sorry, folks. I won't eat this the whole time. Okay. Let's see if anybody got it right. Raise your hand if you got an answer. Lots of people. Jillian, what'd you get?
2. Oh, wait. What do you want like
Probability. So what's your fraction? What over what?
Oh, crap.
Crap is your answer.
Oh,
Mary, what'd you get?
not a fraction.
Not a fraction.
I got 48. Me too. I get 48.
I also got
6 over what? Well, that could be simplified. 6 and 50 are
3 over 4.
good guess, but no.
Or,
James?
I guess. Go on.
148.
Oh, I misread the
Nope.
question.
I don't even know.
That's okay.
It's like, what are the transitions?
So,
Okay.
what is the probability if the number cannot be repeated that your code starts with a 0 or 1?
Wait, oh wait, no. 112.
Probability. Once it over total. What's our total?
48. Well, no.
Oh, I thought it's
120.
Oh,
We know there's 120 codes if we are not repeating. Here's some restrictions on what we have to have. Ours has to start with a 0 or a 1. So there might be another way to do this. This is the way I go about it. I say, okay, I have 4 digits. If this is a 0, that's only one choice possible. How many choices would be left for this one? I had 5 to begin with. I've already taken the 0 out, so I have 4 left. I'll put the 4 down here, so I'm not picking the 4. How many choices for the next one? 3, then 2. So 1 times 4 times 3 times 2 is 24.
Wait, why is it not 2?
Or I could start with a 1, which is the only choice. If I start with a 1, there's 4 choices left, then 3, then 2. 1 times 4 times 3 times 2 is 24. So there's 24 codes that would work that start with 0, 24 more that could work that start with a 1, which makes 48 codes possible that would work over the total 120. What do we get when we simplify that? 2/5. You can use a calculator. You can divide by 2 until you get it if you can't find a larger number. That's a tricky one. Questions on that one? Okay, next page. Number 4, a television news director has 8 news stories to present on the evening news. How many different ways can the stories be presented? I'm going to let you think through that one. Raise your hand if you got an answer. It's okay to be wrong, but you've got something. Is it in the 40,000s?
Oh, yeah.
You got it.
Oh, yeah.
How much?
So, I have 8 news stories to be presented. How many do I have to put here in the first slot?
8.
Am I going to repeat the story on the news?
No.
I'm not going to say the story and then say the same story again during that news section. So there's 7 left, then 6, and down on the line. So in my calculator, 8 times 7 times 6 times 5 is 40,080. 40,000.
32.
Yep. 40,320. Yes, that's what I was going to say next. This is an example of 8 factorial. It looks like exclamation point. You can call it that, but that's not really what we call it in math. We call it factorial. So if you want to practice this, type 8, hit the math key. 8, math, over to PRB. What's PRB stand for? Probability. And then you should see what looks like an exclamation point. Have I taught you factorial before? Some may have just seen it. That's good enough for that one. Factorial is used anytime you're multiplying a number by the next consecutive lower number by 1. So if I wanted to do 8 times 6 times 4 times 2 times 1, of course that's not 8 factorial. It has to be down by 1, all the way down to 1. Read B and see what you come up with. If only 3 of the stories will be presented, how many possible ways can a lead story, a second story, and a closing story be presented? Raise your hand if you have an answer. Just one answer.
I did it wrong.
Is it in the 300s?
Nope. It's in
Yes.
the tens.
I did get a.
Sophia, what'd you get?
Mine's
I got
6.
326.
Yes. So there's not time to tell 8 stories. There's only time for a leading story, a secondary story, and a closing story. So how many choices of stories can I pick from here?
8.
Not going to repeat it, so there's one less. Now there's 7 and 6.
Oh.
So an answer 336. Permutation. I believe this is new for most of you. I'll go through the formula. We'll do some examples, and we'll talk more about what it means and what it really is. So first of all, in the box, permutations of n objects taken r at a time. 30 objects taken 7 at a time, or whatever it is. The number of permutations of, what letter does that say? I can't even read it. R, yep. R objects taken in a group of n distinct objects is denoted by NPR. So let's look at this first example. If it says 10P4, here's our formula to go off of right here. It says to do n factorial. What is our n value? It's the first one, so 10. Then it says to do n minus r, and this first, r is the second one. You can do it with the calculator. You can also think about this. Ten minus 4 is 6, so we're going to be dividing by 6 factorial. Can you see if you do it this way, kind of a shortcut? I have 10 times 9 all the way down on the top, and the bottom I have 6 factorial. Well, I don't need to type all those. I could just type 10 times 9 times 8 times 7 and get 5,040. I don't think I'm going to have you memorize that or ever have to do it this way. But that's the formula. I want to show you how to do it much quicker in your calculator. So in your calculator, type the 10 only. Hit the math button. 10 math over to PRB, probability. Look at your choices. Can you make an educated guess? It's the second choice, right? It says NPR or something like that. And then hit that and then type in your 4. You should get this. I will pause to see if anybody needs help with the calculator. We introed this before, but not much. It might have been common. Yeah, we'll talk about that today and tomorrow. Yeah. Once you get that in your calculator, do B and C. Now let me explain what a permutation is. Permutations, I would like you to write down, maybe circle it, put a star by it. Order matters. Order matters. There's permutations, there's combinations. Combinations we'll talk about tomorrow. Combinations order does not matter. Permutation, it does. Now, the locks that you have outside on your locker, does the order in which you put the numbers in matter?
Yes.
Of course it does. You have to put them in the right order for it to open. Your locks are actually not combination locks. They're permutation locks. It's just nobody ever calls them that. But order matters. So it's not just any combination of three numbers. It's the numbers matter what order. So it's actually permutation lock. So let me tell you an example of this. Let's say I have 10 different candy bars, and I'm going to give them out to 4 people. So let's say I have Snickers, Milky Way, Twix, and Heath. I could give them out to the first 4 people. So let's say this one goes to Jordan, this one goes to Keegan, this one goes to Sophia, and this one goes to Lydia. Would that be different if I did Jordan, Keegan, Sophia, Lydia? Would that be different? Yeah, they're getting different candy bars. So this is telling you I have 10 candy bars. I only listed out 4 because I'm picking 4 of them. But there's also, I can't think of candy bars. Butterfinger.
100 grand.
100 grand. There's 10 total, and I'm picking 4 of them in order matters. So there are, as you can see, a ton of ways to do that because I haven't even introduced any of these yet. This one has less. That would be 7 different candy bars, and I'm going to hand out 5 of them. But there are many, many ways I can do that. Some people get hung up on this. I have 8 candy bars, and I want to hand out none of them. How many ways can I do that? One way. I'm not going to hand out any of them.
Is it always going to be one of the R 0?
Yes. Mm-hmm. So that's what permutation is. It's a group of things, but order matters. Let's look at example 5. Oh, we did 5. 6. How many different ways can 4 raffle tickets be selected from 50 tickets if each ticket wins a different prize? That's important because if the prizes are different, the order in which your ticket is drawn really matters. So read it again, see what you come up with. Did we get a number bigger than all the numbers we've got so far today?
I think so.
Is it in the millions?
Sure.
5 million? Very good. Let me go through a couple ways to do it. Here's one way. I have 4 prizes. They're different. There are 50 tickets I could pick here. I picked one, so now there's 49, 48, 47. That comes out to 5,527,200. Did somebody do it a different way? Keegan, what'd you do?
I put 50 and then the P.
Very good.
4.
Yes. There are 50 to pick from. Order matters. That's why I pick permutation. And I'm going to only do 4 of them. 50 permutation 4 gives you the exact same number. Very good. Sorry, I put that under B, but that was actually part A. I'll give you time to read B and see what you come up with for that. Somebody last hour came up with a really good, quick answer, and it was right. My way's a little bit longer. It might be more helpful for future problems, but there is a quick way to do this. Anybody want to share their answer?
Something over the 5 minutes.
Not bad guess.
4.
Probability. So 4/1, I guess.
Oh,
That's
no,
like a
4
fraction
over
simplified?
like 5.
Okay.
Oh my god. But like simplified one.
I get 1/50, which if you think about it, there's 50 tickets, and I'm gonna pick one. What's the chances I get picked? That's one way to think about it, 1 out of 50. But I kind of want to go about it this way, like I said, in case we need this practice for something in the future. This we know is the total. That's how many different ways the 4 tickets can be picked. And I have 4 tickets to pick. If I'm winning the grand prize, how many people can win this top grand prize? Just me or you or whoever we're talking about. There's only one choice if you have to win the grand prize. So how many would be left for the next choice?
What order is the grand prize?
If I win the grand prize, do I care who wins anything else?
No.
No. So I'm going to win this. There were 50 tickets. Mine is out. So how many are left? There are 49 different people, and I don't care who wins because I've already got my prize. Then there are 48 people that could win here, 47. So there's a bunch of ways I could win the grand prize and other people win their prize. So you multiply the top, divide by the bottom, and it should simplify to 1/50.
What?
You did it?
I think it did. I got 0.02.
Hit math. Your first choice is fraction. There we go. All right. I'm going to read this blurb to the side when we're done, actually. We're going to look at the problem first. Find the number of distinguishable permutations of the letters in soccer and swimming. Let me explain what I mean by distinguishable. Let's say I have a hat and I have 4 letters inside. If I pull out the M, then the I, then the S, then the S, oopsies, and you pull out the M, the I, this S, and this S, isn't it going to look the same?
Yeah.
That's not distinguishable. So those would be considered the same outcome. So I want to know how many different ways I can put these letters in a hat and make a different arrangement. MISS is the same arrangement as MISS. So I have those letters. How many different ways can I arrange those letters? Here's how you do it. The top is how many total letters you have. 1, 2, 3, 4, 5, 6. The bottom, we worry about our repetition. So I have a letter here that's repeated twice. Since it's repeated twice, I put 2 factorial. If another letter was repeated twice, I put another 2 factorial. If a letter was repeated 3 times, I would put a 3 factorial in the bottom. However you want to calculate that, go ahead. Who said that? Oh, yeah, thanks. I was at 24 times 3 and you beat me. What's your question?
360. I got 360.
Oh, maybe it is 360. 24 times 3. I haven't finished calculating yet. 1, 2, 3, 4, 5, 6. I get 72. What does my paper say? Oh, I'm sorry. I missed the 5. Yep, that would definitely make a difference. Sorry. My bad. Yeah, sorry. I made you mess up. Sorry, 6 times 5 times 4 times 3. What was it, 360? Thank you. My bad. Okay, do swimming.
It gets multiplied down there.
Yep, so if you're doing it, you might have to put a parentheses. $10,080.
Oh. Oh, parentheses like that.
Now let's talk about this little blurb off to the side. I think when I show you guys how to do this and we do 2 examples, it's fairly easy. If I had said, read this on your own, not helping you, I have a feeling we would struggle with reading this math context. Am I right?
Yeah.
It's something we need to get a little better at. Usually I read it first, then I kind of dissect it. But I think I wanted to do it this way so you know what's actually happening. You know how to do the problems. Now see when I read this if it makes more sense. Here we go. Permutation, which means order matters, with repetition. I have 2 C's or 2 M's, etc. The number of distinguishable permutations of n objects, 6 objects, where one object is repeated S1 times, another is repeated S2 times, and so on, is blank. So they've shown you we have n factorial, that is your number of objects. There's no saying how many times things are going to be repeated. We have to be generic, which kind of makes it more complicated when we look at it sometimes. So if something is repeated S1 times, this was repeated twice, I do 2 factorial. If the next thing is repeated S2 times, say it's repeated 3 times, I have to do that. It's multiplied. Do you see why there's a dot, dot, dot? There may be more or there may not be until we get through all of the letters. Yes.
So what if it's not repeated 2 times and it's just repeated 3 times?
Then, so like if I have A, B, 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 C.
Yeah.
1, 2, 3, 4, 5 over 3 factorial.
Okay.
Yeah, and then if it was D, D, it would be that. So just 1 letter and however many times that was repeated. All right, your homework should be there in your packet. Bless you.